As you can see, I divided today's presentation into 6 parts: introduction and backgrounds, concept development stage, engineering development stage, post-development stage, the challenges of the program, and the summaries and lessons learned. First, begin with the part 1, introduction and the background. So, what is auto-driving system? Auto-driving system, which can also be called as autonomous vehicles, also known as driverless cars, computer-driven cars, or wheeled mobile robots. It is an intelligent car system that realizes driverless driving through an onboard computer system. Auto-driving technology has a history of decades in the 20th century and showed the development of it in the early 21st century. Auto-driven cars rely on artificial intelligence, visual computing, radar, monitoring devices, and global positioning system to work together to allow computers to automatically and safely operate modern vehicles without any human active operations. The essence of auto-driving system is to use artificial intelligence to replace human labor in specific scenarios to achieve an improvement in work efficiency and a reduction in labor costs. The main driving technology in the high-speed open scene is the most difficult and has the largest imagination. It is also gathered the top companies in the autonomous driving industry, but it is far from the final commercialization and profitability. Auto-driven system has already formed part of commercial applications in the fields of indoor robots, AVGs, and so on. Also, they are gradually touching in fields such as building distributions and park logistics, and logistics and manned vehicles. Today, all of this has brought a bright future of unmanned driving. The development of science and technology promotes industry, social progress, and the development history of human society also prove this point. Whether it is the Industrial Revolution or the subsequent revolutions, it has brought huge efficiency improvement to society. Autonomous driving is a trend in the future. It will bring fast, worry-free, and safe travel for individuals and society, and upgrade the original mode of transportation to more efficiency travel. Then we're going to talk about why do people highly need auto-driving system. First, auto-driving system can also help realize automatic parking. Driving as a self-driving car can save you a lot of time in finding parking spaces and make users' life and work more efficient. Secondly, auto-driving technology can effectively avoid congestions. The self-driving car will automatically adjust the route according to the real-time road conditions and safely send you to your destination in the shortest time. Third, auto-driving technology makes travel convenient. Self-driving cars can allow the elderly, the disabled, those without the driver's license to travel more freely. Fourth, auto-driving system technologies make travel convenient. Self-driving cars can allow the the people to be more environmentally friendly and accelerate and decelerate in time according to the road conditions during driving, and minimize carbon dioxide by 300 million tons per year. Fifth, auto-driving system technology can liberate the eyes. If the system is finally perfected, users will no longer have to stare at the front when the car is driving and will have more time to read, rehearse, work, or sleep. Now we come to the part 2, concept development stage. First, we're going to talk about the need analysis. Auto-driving system usually must include video cameras, radar sensors, and laser ring finders to understand the surrounding traffic conditions and navigate the road ahead through a detailed map. All these achieved through Google's data center, which can process a large number of information about the surrounding terrain collected by the car. The structure of the auto-driving system is composed of following parts. First, the laser radar to scan the corresponding 6-meter radius may be present in the above board computer by the way of a 3D picture. The front camera is mainly used for the identification of traffic lights and assist identification with cooperate of the computer. The left rear wheel sensor can perform computer positioning through a lateral movement to establish the correct position for driving on the road. A total of 4 front and rear radars are installed in the vehicle, 3 in the front and 1 in the rear. They are mainly to use to measure obstacles on the road during driving. The master computer is the brain that receives the issues instructions. The auto-driving system adopts binocular camera system to automatically collect road condition information from 1 to 200 meters in front of the vehicle, including ground markings, isolation belts, lane marking recognition, roadblocks, and so on. At the same time, the auto-driving system is mainly composed of hardware and software. The hardware part is composed of binocular camera device, image processing platform, software library, control interface, and actuator. The software part mainly include target recognition, motion parameter measurement, and image processing, and so on. The system software automatically decides the speed of the car, the direction and position of the car, automatic overtaking, emergency braking, car whistle, light control, uses a closed-loop system for steering wheel control and speed control. It can be used for auto-driving cars on the highways, avoiding traffic accidents, and has a simple structure, low cost, and good reliability. Next, focus on the timeline. We will know the history of the development of auto-driving system. In 1939, Norman created the first auto-driving car at the General Motor Exhibition. The principle is guided by a radio-controlled electromagnetic field, where it is generated by metal nails embedded in the lane. By 1938, 1958, people had embedded a sensor on the front of the car. The sensor was used to detect the current flowing through the wires embedded in the road. In the 1977, the Japanese improved on this idea, using a camera system to relay data to a computer to process road images. However, the speed of the car is limited and can only be lower than 20 pmf. In 1995, the U.S. government organization committed to safer and more legal development of autonomous driving technology and invested in it. They held a project, and in this project, Dick Mann's self-driving car achieved nearly 2,000 kilometers per hour at a maximum speed of 130 kilograms per hour, almost completely automatically, driving a perfect end to this plan. In October 2015, Tesla Motors announced that it has enabled the auto-driving function and released a software update for its Model S vehicles. Model S software enables the cars to follow the lanes, to drive automatically, and switch lanes to or park according to the driver's instructions. The realization of these self-driving functions makes a Model S one of the first public available auto-driving cars. So far, no company has successfully researched the ability of a car to achieve fully automatic driving on the main road. But with the continuous improvement of auto-driving system and the improvement of science and technology, our vision of autonomous vehicles will eventually be realized, and there will be more than 125 million between 2018 and 2022. A passenger car with embedded connectivity is on the market globally. We divided auto-driving system development into 5 stages through the SAE standards. Level 1 is the lowest level of the automation, hardly being described as driverless. The vehicles has a single aspect of automation that assists the drivers with ADAS. The level 2 is where the vehicle is able to control both the steering and accelerations and decelerations. ADAS capabilities, although this allows the vehicle to automate certain part of the driving experience, the driver remain in complete control of the vehicle at all times, unable to detect the environment around them. Level 3 vehicles contain the lowest system that is classified as a automatic driving system, as opposite to a manual system. With the more advanced technology, level 3 vehicles can make informed decisions for themselves, such as overtaking slower moving vehicles. However, unlike the higher rated autonomous vehicles, people override is required when the machine is unable to execute the task at hand or the system fails. The level 4 stage is high automation driving, and the key difference between level 3 and level 4 automation is that the level 4 vehicles are able to intervene themselves if things go wrong, or there is a system failure. In this sense, these cars are left completely to their own devices without any human intervention in the vast majority of situations. Although the option to manual override does remain in difficult or peripheral circumstances. Similarly, the level 5 full automation driving vehicles do not require human attention. However, the key difference is the quality, with level 5 vehicles providing a much more responsive and refined service, comparable to that of adaptive and situational manual human driving. Obviously, we current in the second stage, a partial driving automation phase, and trying to put conditional driving automation cars on the road. But with the technology improvement, the final stage will be achieved. Auto driving system is not an independent system. It is consisted of seven subsystems. The first is identification. Those are the eyes are used to identify surrounding vehicles, obstacles, and pedestrians on the road. And the second part is radar. It is more common on the roof of the car, like a hat that keeps spinning. The third part is the decisioning making part. Make full use of information for understanding and analysis. Form a certain degree of knowledge accumulation in the brain. The fourth is positioning. Positioning in robot system can plan the path. The fifth is communication and security. It's like the V2X contains personal information about the car and its users. User identification, verification, and data encryption system is very important. The sixth part is human and computer interaction. HMI noticed by the users in the most intuitive and convenient way, so that the driver will notice as soon as possible. The final subsystem is high position map. High position map will become a must need if you want to achieve level 3 autonomous driving. The third part is engineering development stage. We will talk about the first development needs is the precision layer. First, we need to develop is the cameras structure. The camera structure is simple. The detection distance is longer, but it's too easy to be affected by the environment and weather, and it is the first sensor to be used. Next, people develop the millimeter wave radar. It is also is one of the most used radar right now. It is composed of an ADMA, a chip, and an algorithm, widely used in high driving automation, which means it's the level 2 to level 3. And the third we need to most focus on, and will be widely used in our future, is the radar. The radar use the time of flight sensor. It's formed by mixing light and radar. For the future, a variety of radar sensors fusion is indispensable. The second part is decision layer. It's kind of like a chip to make a decision of the car's movement. First, people develop CPU. It is a small number of cores, but each core has a large enough capacity to store a large amount of data for performing complex computing tasks. Then people found GPU. GPU compared to CPU is a number of cores several times that of the CPU. Each core has a small capacity and limited logical computing power for simple but large tasks. Then people found FPGA. FPGA for instruction, simple and lower power thread operation. The combination of the two can realize a chip that performs a large number of experimental calculations in the cloud. Right now, people focus on ASIA chip. It's a smaller chip in size, lower in cost, and low in power consumption, so they have better stability and are more suitable for specific functions. The third part we will be development is execution layer. First, people use ESC at the beginning of the research of auto driving systems. From maximum hydraulic braking to the combination of electronic control and hydraulic pressure, and then gradually turning to pure electronically controlled mechanical braking and intelligent wire-by-wire control. But right now we used MK and CE the most. That will make the pressure dynamics of automatic driving higher, and at the same time shorten the braking distance brought by electric trigger emergency braking. The fourth part is post-development stage. It is about the future progress and the development of auto driving system. First, we should upgrade the computer power of the brain. It's like level 1 and level 2, because level 1 and level 2 require less than 10 tons of computer power, but level 3 that people currently working hard to achieve, conditional autonomous driving, that requires computing power is 30 to 60 TOPS, and the level 4, the high autonomous driving level is already greater than 100. Second, we should realize that the upgrade from level 2 to level 3 and make level 3 become the normal cars on the road is a big step of auto driving cars, because level 3 system must ensure the accuracy of detection and control, so the interaction of virus sensors is required. And also level 3 ensures that there is a certain degree of the redundancy at the entire level of precision, decision making and execution. And the upgrade of interface display mode is also needed, and when mid emergency, ensure the function will not exit during the maximum period from the failure to the driver taking over. Third, we must focus our eyes on the moral and ethical system, because right now we have some instructions to upgrade that system. First, special regularity agency should be established to control and deploy autonomous vehicles. Second, increase the scale of road testing of autonomous vehicles. Third, different reductions, measures, and safety factors rating need to be adopted according to the different levels. Fourth, redefine the scope of person who need to be held accountable in accident. Although the prospects for auto driving system to change life are bright, on the road leading to its kind of beauty, autonomous driving still faces many difficulties and challenges nowadays. Among them, on the one hand, there are technical challenges. On the other hand, there are moral questions and legal gaps. First, the conceptions of decision making and planning. The so-called position is that the vehicles need to be perceive the surrounding objective environment, such as how many people are there around, how many cars are there around, and where are their path of action is. And decision planning is how to avoid obstacles after fully calculating the perceived content and choose the best path to act. Second, with the continuous enrichment and stockpiles, the safety of the vehicles has become more and more guaranteed. But the cost of the cost of self-driving vehicles is getting higher and higher. In addition to manufacturing cost of the vehicle itself, the auto driving also needs to rely on high precision maps. High precision map is a map dedicated to autonomous driving. Unlike traditional maps, high precision maps can be accurate to the lane level. What is curve native of each turn of the lane, and what is gradient of each uphill. For moral questions, I would like to ask, when a self-driving vehicle loses braking ability during high-speed driving and hit passers by when driving straightly, and the steering will cause collisions in the vehicles. So how to choose automatic driving in this situation? Perhaps we still cannot answer these questions nowadays. Also, autonomous driving may also have some hidden dangers at the safety level. For example, many car systems shown in some futurist car-themed movies were compromised by hackers, causing all vehicles to lose control and causing social security problems. These problems may seem very absurd. Some may never happen. Some may always happen one day. And these are the tasks that autonomous driving will face in the future. Finally, the summary and lessons I learned from the study of auto driving system. During this period of time, with my initial interest in the autopilot system technology, I researched and expanded it. I read a lot of materials and research, and I have the following experience and summary. Before I deeply understand autonomous driving system, I think that autonomous driving cars are just a simple conversion of human functions into autonomous control of the car. However, after understanding the continuous improvement and development of autonomous driving technology for more than a half a century, I understand it that autonomous driving technology requires very complex software and hardware to work together to realize the people's dream. Through the technic cooperation of sensors, AI chips, and thread control of those software and hardware we mentioned before, the road and the surrounding environment can be sensed, and the various actions of the cars can be controlled to achieve the safety of the people and reliable and accurate driving on the road. So, with the development of science and technology, the future society will be more intelligent, convenient, and low cost. And autonomous vehicles are like small driving robots, bring people an unpredictable technological experience and making people feel the charm of life. This field will be continue to flourish and the future can be expected. Thank you for listening. That's all of my presentation.